Okay, welcome back. So now we're going to be looking quickly at how we do multiplication and division with algebraic fractions. So let's bring up an example and have a look. So our first one is x divided by 3 multiplied by 3 divided by x. Now, with our rules of multiplying fractions, we remember that when we are multiplying, we're actually going to multiply the two numerators and then multiply the two denominators. And we can just remember that as top times top, bottom times bottom. In this case, x times 3 is 3x, and 3 times x is 3x, which means that we have the same numerator and the same denominator. Using some basic math, we can divide both the top and the bottom by 3x and get 1 over 1, which leaves us with 1 as our answer to the first one. Now, that's a really easy one. Now, with this one here, we have to remember that when we are doing a division problem with our fractions, we want to change it to a multiplication problem. And the way we do this is we keep our first one, so we keep our a over 4. We change this to a multiplication, and then we take the reciprocal. And the reciprocal just flips this furthest fraction on its head. So all we have to do is replace which is the numerator and which is the denominator. So instead of a over 2, it becomes 2 over a. Now, when we are doing a problem like this involving an a, really good idea to draw something that distinguishes it from a 9. I do this all the time and I always make this mistake, so please make sure you're not like me and actually make that little distinction or add some kind of flourish so you know it's an a. Right, then we just do our top times top, bottom times bottom. A times 2 is 2a, and 4 times a is 4a. Now, can we see some common factors? Yes. So in the first one, the coefficient has a common factor of 2, and both of them are multiplied by a, which means a is a coefficient as well. Right? So you can do this separately. We can do 2 divided by 2, which is 1. 4 divided by 2 is 2. And then a divided by a is 1 and 1. So 1 times 1 is 1. And 2 times 1 is 2. And so we end up with a half as our simplified answer. Okay, let's move on to something a little bit more difficult. So now we have x squared multiplied by 3 over x. So how can we do this? Well, the first thing we can do is recognize that this can be made into a fraction if we'd like. And instantly we can do top times top and bottom times bottom. Or you can just remember that when we are multiplying in a whole number or a non-fractional quantity, we can just multiply the numerator. Right, so in this case, we're going to multiply the top and we're going to multiply the bottom. So 3 times x squared is 3x squared, and 1 times x is just x. Now, because when we expand this out, it's 3 times x. I'll actually use the dot times x. Then we are dividing it by x. And when we divide by x, or 1 times x, we can cancel one of the x's out as a common factor. Then we're left with 3x over 1. Anything over 1 is in fact just the number on the numerator, so it becomes 3x. Okay? You do not have to do this step in your working, it's purely illustrative. Okay, so that's solved. We're left with 3x. Now, for this one here, we have the same idea, but it's back to front. So you can just multiply in the b, you can add the 1 if you would like, it's totally fine. So then it becomes b squared times 1, which is just b squared, and 1 times 2b, which is just 2b. Once you are done with that, you can then see what a common factor between them is going to be. In this case, obviously, there is only one common factor between these two values. And so we're going to divide both the top and the bottom by b. b divided by b is 1, and then b squared divided by b just leaves us with b. That means our total answer is just going to be b divided by 2. And because there's no common factor left over, we are done with our simplification. Okay, next one, we have 3x over 4 multiplied by 2 over x squared. Right, so let's get started. First things first, let's combine these together. So we can obviously do the top times top and bottom times bottom number, but we can also cancel preemptively if you would like. That means we can look for making an individual fraction a little bit more simple before we do any operations with it. So let's get started with just multiplying again. So 2 times 3x all over 4 times x squared. 2 times 3x is just 6x, and 4 times x squared is 4x squared. So now we're looking for common factors. What about between the 6 and the 4? The only common factor there is a 2. So we'll divide the 4 by 2 and get 2, divide the 6 by 2 and we get 3. And then we have a common factor of the x between the x and the x squared. So dividing both by x, we get 1, and we're left with just our x. So that leaves us with 3 times 1, which is 3, all over 2x. Now this can be a little bit messy. And the reason it's I bring this up is because sometimes when I'm looking at my working, it's obvious that I could have spaced it out a little bit more and made it a little bit easier to follow what I was doing. And I encourage you to do a little bit more space for your answers just to make sure that that doesn't happen. Okay, next one. So we have 5 over a, and we are dividing it by 10. And we don't actually want to do dividing by 10. We want to make all of our problems into a multiplication problem. So in this case, we're going to change this to a fraction as well. And then we're going to do our keep swap flip. So we're going to keep our 5 over our a, multiplied by our reciprocal, which is 1 over 10, which we've just flipped. In this case, we just have to do 5 times 1, which is 5, and then we multiply our denominator, a times 10, which is going to be 10a. And we're not done there because we have to look for common factors. So obviously there's no common factor for our polynomial, but there is between our 5 and our 10. So if we divide the top by 5, we get 1, and the bottom by 5, we'll get 2, and we'll be left with 1 over 2a. And that's our simplified fraction. Now, this one here is a little bit, again, something that you can do that way if you would like to, or you can slightly change. So let's have a look at this. It's 2ab divided by 3 multiplied by 6 over ab squared. Now I can't see any way to simplify it before I start, so I'm just going to get into working with it. So first up, we can do the full multiplication, and we can do 6 times 2ab. So 6 times 2ab divided by 3 times ab squared, which is 12ab divided by 3ab squared. Right, so let's do the coefficients first. What's the common factor between both of them? Well, the common factor will be 3. So if I do that, then I can get rid of the 3 and turn it into 1 and divide the 12 by 3, and I get a 4. If they're both the a's on both the numerator and the denominator, we can get rid of both of those polynomials. And because b is a common factor here as well, we can get rid of the top one and we can get rid of this exponent here, leaving us with 4 divided by b. And we're done. And the reason why we are doing this is kind of revealed. This looks super complicated and is super annoying. But this, if our formula is reduced to this just after we simplify it, then we should do our simplification. Any further substitution or algebraic operation here will be much easier with the second one than the first one. Okay, let's do this one. We have 8ab over 5, and we're going to divide it by 4ab over 15. Now, we want to turn this into a multiplication problem every single time. So let's do that immediately. We have 8ab over 5 stays the same, change the division to a multiplication, and then we take the reciprocal of the last term and we flip it. Okay, now that that's done, we can start to think about how we simplify. So, when we have combined this all together, we can do this 2 kind of ways. We know that these are going to be multiplied together. We know that's going to happen. So we can kind of cancel by just thinking about what the end result will be rather than doing a full multiplication. If we know fundamentally that at the top there will be an A and at the top there will be a B, then we can start cancelling not only based on vertical cancelling, but we can start cancelling based on diagonal factors. So in this case, we know when we multiply this, there'll be an A and a B on the top. And if there's an A and a B on the top, then we can cancel both of them. And you don't necessarily have to do it this way either. You can leave our values up the front. You can leave our coefficients up the front. And we know we can multiply them at any point. And we can keep everything separated if you would like to. You don't necessarily have to perform the full multiplication because it might be unnecessary. You might not even need to. You can keep this all separate. All right. In this case, because our A and our B are both up the top, then they all cancel. They all cancel. A divided by A is 1, B divided by B is 1. And that means there'll still be whatever on top divided by 1 times 1 times 1, which means it doesn't need to be there. And the same can be said for our values here. We can also cancel our numerical values as well. All right, they follow the exact same rules. So we can cancel, or we can rewrite this slightly. They follow the same rules as with the algebra. Okay, so we can think about these as 2 separate fractions we're multiplying together, and we can find common factors to cancel out of them as well. If I divide the top and bottom by 5, or 5 divided by 5 is 1, 15 divided by 5 is 3, and in here I can also see that I can divide both of these by 4. 4 divided by 4 is 1, and 8 divided by 4 is 2, and we're just left with 2 times 3, which is 6 over 1, which is just 6. So you can also use cancelling to simplify out mathematics you don't necessarily want to do, as long as there's common factors between them. And if you're wondering how I got just in here where I swapped these around, 5 and the 4, so it's a 4 and a 5, it doesn't actually matter the order. So 3 times 2 is still 2 times 3. They are both the same. So when it comes to multiplication, when we have these combined individual coefficients and pronumerals, we can order them however we like, in the same way that b times 2 is 2b. They're the same thing. Alright, that's it for this video. Hopefully it was helpful, and I will see you in the next one.